let's start by reviewing the rules and definitions from the last tape. Okay. Definition number 1, the idea of a to the nth power. This means a as a factor n times. Okay. A to the 0 power is 1 if a is not 0. And a to the minus n power is 1 over a to the n power. This is how we handle negative exponents. Okay, now n here can be either positive or negative. Let's look at what happens to this formula in various instances. A to the minus n is 1 over a to the n. So if, for example, n is equal to 2, we get that a to the minus 2 is 1 over a to the second power, 1 over a squared. On the other hand, if n is equal to, say, minus 3, if n is minus 3, we get a to the minus 3, or a to the plus 3 power, is 1 over a to the minus 3 power. First time around, I let n be 2. A to the minus 2 is 1 over a to the 2. The next time, n was minus 3. A to the minus 3, or a to the plus 3, is 1 over a to the minus 3. So you see that this rule can be used in either way. If you have a negative exponent in the numerator, in this case, a to the minus 2, you can rewrite it as 1 over a squared. On the other hand, if you have your negative exponent downstairs in the denominator, it can be moved upstairs with the positive exponent. And remember, in the last tape, we decided that we will consider an answer to be in simplest form if it involves positive exponents only. So it may be necessary to use this rule in either of these two ways. Okay, let's go back over here. Rather, it's definition. Let's now look at our rules. In these, I will assume that a and b are real numbers and that m and n are integers. And where necessary, if you ever see division, we will assume that we do not have division by 0. Okay? In rule number 1, a to the m times a to the n is a to the m plus n. We are multiplying with the same bases. We will keep the base and add the powers. A to the m over a to the n. We are dividing. They have the same bases. We keep the base and we subtract the powers. A to the m to the nth power. Notice that the base appears only once. Okay, it's not the same as rule number 1. A to the m to the n is a to the mn. We multiply the powers. It's a power to a power, and we multiply the powers. This, we had the base appearing twice. We kept the base, and we add the powers. A product to a power. Okay, a product to a power, we simply take each factor to the power. A, b to the n is a to the n, b to the n. And a quotient to a power, a over b to the nth power, it's the numerator to the power over the denominator to the power. In examples 2 and 3, we're assuming, of course, that we're not dividing by 0. You might want to jot these down. We're going to be using these. I will mention the numbers of the rules as we use them in the examples. By the way, rule number 1 and rule number 4 can be extended. For example, in rule 4, you might have a, b, c to the nth power. 3 factors would be a to the n, b to the n, times c to the n. Okay, and also in rule 1, we could have it extended more than two factors in the product. Okay, let's start working out some examples. Start simply, and then we're going to get into some more complicated ones. Example number 1, 3x squared y to the minus 4th power times 2x to the minus 2 power y to the 3rd power. Okay, the big thing to remember is that these rules that I've given you are good for positive or negative exponents, or 0 exponents. These are integers here. Okay. Doesn't matter if the powers are positive or negative. You use those rules. Okay, now, in all of the examples, the idea is to simplify the algebraic expression so that you get a final answer which involves only positive exponents. Okay. In a problem like this, I'm going to rearrange the terms so that we have 3 times the 2, x to the second times x to the minus 2 power, and then the y is y to the minus 4, y to the 3rd. Okay, I'm just rearranging the order of the multiplications using various laws, for example, the commutative law, associative laws. Now, it's a good idea to just make up your mind. Say, I usually put the constants first, then say the x's, the y's. I use alphabetical order on the variables, just so that I can keep track of what I have. Now, 3 times 2, that's, of course, just 6. X to the 2 times x to the minus 2. This is an example of rule 1. We have the same base. X to the 2 times x to the minus 2. We will keep the base x and add the powers. X to the 2 times x to the minus 2. We keep the base and we add the powers. And the same thing on the y's. Y to the minus 4 times y to the 3 is y to the minus 4 plus 3. Okay, so we used rule 1 twice. Okay, we are multiplying. They have the same basis. We keep the base and we add the powers. Okay, let's see what we get here. 6. Now, 2 and minus 2, of course, is 0. Minus 4 and plus 3, that's minus 1. So we get 6x to the 0, y to the minus 1. Now, x to the 0, by definition number 2 here, x to the 0 is simply 1. X to the 0 is 1, and y to the minus 1 power is 1 over y to the first power. Okay, so we're using definitions 2 and 3. Definition 2, x to the 0 is 1. Definition 3, y to the minus 1 power is 1 over y to the first power. Of course, you can leave out the first power. We just see y. We know it's y to the first. Okay. This is, of course, 6 over 1, 1 over 1. We're really multiplying fractions. We multiply the tops, divide by the product of the bottoms, and we get a final answer of 6 over y. In our next example, minus 8 a to the 9th b over 24 a cubed b to the 5th. We want to simplify this. We don't want to have a's in the numerator and the denominator. We want to get rid of we want to have it only in the numerator or the denominator. We're going to simplify as much as possible here. First thing I'm going to do is to rewrite this in the following form. I'm going to have the constants, the a's, a to the 9th over a cubed, and then the b's, b over b to the 5th. Of course, if you were to multiply these fractions, you'd get the problem that we started with. Just a little, what I'm doing basically is breaking it up into smaller problems that are easier to handle. Okay, now, 8 goes into 24 3 times, and minus 8 over 24 can be rewritten as minus 1/3. Or you can cancel the 8 into 8 goes once, 8 into 24 3 times. Okay, now you could do the same kind of thing on the a's and the b's, but I don't want to. I want to instead use the rules, and you'll see in the next example why I'm insisting on you using the rules. Okay. If you had canceled, you would have 9 a's on the top and 3 a's on the bottom. You would cancel, you'd be left with a to the 6th on the top. Using the rules, we're using rule 2, by the way, in this example. A to the m over a to the n is a to the m minus n. We are dividing, same base. We keep the base, we subtract the powers. A to the m over a to the n is a to the m minus n. Let's go back over here. A to the 9 over a cubed is a to the 9 minus 3 power. And here, this is b to the 1. b by itself, it's b to the 1 over b to the 5th, so it's b to the 1 minus 5 power. So we have minus 1/3 a to the 6th b to the minus 4. And this gives us minus 1/3 a to the 6th b to the minus 4 using definition 3. B to the minus 4 is 1 over b to the 4. And our final answer, if I can get it in here, okay, this is a to the 6. It's really a to the 6 over 1. So let's take the product of the numerators and divide by the product of the denominators. On the top, we'll have just minus a to the 6th. And on the bottom, 3b to the 4th. The minus sign actually could be either in the top or in the bottom or out in front of the fraction. Okay, minus a to the 6th over 3b to the 4th. There was nothing wrong with, say, this answer here, except we would prefer to have only positive exponents in our answer. Okay, now, as I mentioned before, a lot of you figure you could just cancel the a cubed into the a to the 9th, get the a to the 6th, the b into b to the 5th, and get b to the 4th. And you certainly could in this particular example. Now let me give you an example with negative exponents where it's much easier to use the rules than to try to cancel. The same kind of format as the last problem, but now we'll have negative exponents. Minus 4, a to the minus 2, b to the minus 5, over 6, a to the minus 1, b cubed. Okay. First, I'll rewrite it as minus 4/6 times a to the minus 2 over a to the minus 1 times b to the minus 5 over b cubed. Okay, now on the constants we are going to cancel. We see that 2 is a factor in both the top and the bottom. We divide the top by 2, we get 2. Divide the bottom by 2, and we get 3. We have with the minus sign. So we have minus 2/3. Here we have a to the m over a to the n, rule 2. It's a to the m minus n. So it's a, keep the same base, and subtract the powers. Minus 2 take away a minus 1. And here, b to the minus 5 over b to the 3, it's b to the minus 5 minus 3. So we have minus 2/3. Minus 2 take away a minus 1 is minus 2 and plus 1, giving us minus 1. And b to the minus 5 minus 3 is b to the minus 8th power. This gives us minus 2/3. A to the minus 1 is 1 over a to the 1. And b to the minus 8 is 1 over b to the 8. So our final answer is now multiplying the numerators and dividing by the product of the denominators, minus 2 over 3a b to the 8th. Now in this example that we just worked out, I just want you to see that you couldn't just cancel the a's and the b's the way we did in the example before. Okay, once you have the negative exponents, okay, it is not obvious how to cancel. In fact, what you'd have to do is use your definition number 3, okay, and make this 1 over a squared in the numerator, 1 over b to the 5th in the numerator, 1 over a, okay, and then you'd have to start worrying about complex fractions. It would be a much more complicated example to work out. With these rules, there's basically no difference between positive and negative exponents. Okay, a and b are real numbers, m and n are integers, nothing about positive or negative. Okay, you can't cancel to begin with the way you could if they were all positive exponents. You just use the rules, and it falls out very nicely. Okay, let's try another example. Minus 3 x to the 3rd power, y to the minus 4 power, quantity squared. The whole thing squared. We're going to start by using rule 4 here. Okay? we have like a, b, c to the nth power. We're going to make it a to the n, b to the n, c to the n. Rule 4 over here was the one that says a product to a power. Okay, you take each factor to the power. And as I mentioned before, we can extend it. There can be more than 2 factors in there. This is like a, b, c to the nth power. We're going to make it a to the nth, b to the nth, c to the nth. This is using Rule 4. Now, on the next step, maybe I'll put a little 4 in here just so you remember this was Rule 4 to get from here to here. Now, we're going to need Rule 3. Rule 3 is the one that tells us how to handle a power to a power raised to a power. Okay, Rule 3, a to the m to the nth power is a to the mn. Okay, it's not the same as Rule 1. Rule 1, you have the base occurring twice. You keep the base, you add the powers. You're multiplying. In Rule 3, you're taking a to the m and raising that to the nth power. The base is only once there. You keep the base and you multiply the powers. Okay, so using Rule 3, minus 3 squared gives you 9. X cubed squared is x to the 3 times 2 or 6th power. And y to the minus 4th squared is y to the minus 8th. Okay, 9 x to the 6th. And y to the minus 8 is 1 over y to the 8th. There we're using our third definition. Y to the minus 8 is 1 over y to the 8th. And since this is really just over 1, we multiply, we get 9x to the 6th over y to the 8th. Okay, in our next example, we're going to work with minus 3x squared over 2y to the minus 3. The entire fraction raised to the 3rd power. We want to simplify this as much as possible. Okay, and it's an example of Rule 5. Okay, the last rule that we have on our list. We haven't seen an example of this yet. This is a fraction to a power. We take the numerator to the power and divide by the denominator to the power. Okay, so that's step 1. We're using Rule 5. Rule 5 to go from here to here. Minus 3x squared cubed over 2y to the minus 3 cubed. Top to the power over the bottom to the power. Now, let's continue. Now what we have on the top and on the bottom are examples of Rule 4. A product to a power. We take each factor to the power. A, b to the n is a to the n times b to the n. And that's what we have up here and down here as well. A, b to the nth power is a to the n, b to the n, and also down here. So we'll take minus 3 to the 3rd power, x squared to the 3rd power, 2 to the 3rd power, y to the minus 3 to the 3rd power. This was by using Rule 4. Minus 3 to the 3rd, x squared to the 3rd, 2 to the 3rd, y to the minus 3 to the 3rd. We're distributing the power all the way through. We can do that because this is all multiplication. We could not do it if there was an addition sign in there, okay, or subtraction. It doesn't work for sums and differences, only for products, and over here for quotients. Okay. Now we're going to use Rule 3, which tells us that a to the m to the nth power is a to the mn. A power to a power, we multiply the powers. Okay, and that's going to come into play over here and here. Okay, so we have, let's just keep the minus 3 cubed. We won't work on that this time. And the 2 cubed. We're using Rule 3. This makes it x to the 6th, y to the minus 9th. We're multiplying the powers. 2 times 3 is 6, minus 3 times 3 minus 9. Now, let's just simplify. Minus 3 cubed means minus 3 times itself 3 times. Minus 3 times minus 3 times minus 3. Minus 3 times minus 3, that's 9, times minus 3 is minus 27, x to the 6th, over 2 cubed, that's 2 times 2 times 2, 8, y to the minus 9. And we can make this minus 27, x to the 6th, over 8. And the y to the minus 9 downstairs can become y to the 9 over 1. You can write it upstairs. That was using definition 3 that I mentioned before. In this example, if you think of if n is minus 9, 1 over y to the minus 9, okay, would be the y to the minus 9, y to the plus 9. The negative power downstairs became a positive power upstairs. You've seen it in reverse in this example over here. A negative power upstairs becoming a positive power downstairs. And now we have a negative power downstairs moving upstairs and becoming a positive power. Okay, this gives us a final answer of minus 27 x to the 6th, y to the 9th, over 8. Okay, let's try some more examples. 3x to the 5th, y to the minus 4, over xy to the minus 1, all raised to the minus 3 power. Of course, if you want to try this problem on your own, you can shut off the machine and tune us back on after you've finished the problem, or gotten sick of it, one or the other. Okay, we're going to start with Rule 5, the one that said a fraction to a power, it's the numerator to the power over the denominator to the power. So we'll have 3x to the 5th, y to the minus 4, to the minus 3 power, over xy to the minus 1, to the minus 3 power. Notice it is the entire fraction to the power, so it's the top to the power over the bottom to the power. Now we're going to be using Rule 4. That's the one that says, say, a, b, c to the nth power is a to the n, b to the n, c to the n. That enables us to distribute the power through the factors. So we'll have 3 to the minus 3, x to the 5th to the minus 3, y to the minus 4th to the minus 3, over x to the minus 3, y to the minus 1 to the minus 3. Now, Rule 3, that's the one that says when you have a power to a power, you multiply the powers. Okay, let's leave the 3 to the minus 3 by itself. We won't worry about that now. X to the minus 15th, y to the plus 12, over x to the minus 3, y to the plus 3. All right, now we're going to break the problem up the way we did the earlier ones. We can think of this as 3 to the minus 3 over 1 times x to the minus 15th over x to the minus 3 times y to the 12th over y cubed. This 3 to the minus 3 upstairs we can, of course, rewrite as 1 over 3 to the 3 downstairs. 3 to the minus 3 upstairs, using our definition, becomes 1 over 3 to the 3rd power. Now, these are examples of Rule 2. You're dividing, same base, you keep the base and you subtract the powers. So we get x to the minus 15, take away a minus 3, and here y to the 12 minus 3. Okay, that's 1 over 27. 3 cubed gives us 27. 3 times 3 times 3. X to the minus 15 minus a minus 3. Minus 15 minus a minus 3 is minus 15 plus 3. That's minus 12. So we get x to the minus 12, and here y to the 9th. And of course, x to the minus 12 can be rewritten. I'm a little short of space, so I'm going to rewrite x to the minus 12 here as 1 over x to the 12. That was x to the minus 12. We made it 1 over x to the 12, giving us a final answer of y to the 9th, multiplying the numerators, over 27 x to the 12. By the way, I don't want you to think that this was the only way to handle this example. Let's go back and look at the example. Okay, I started the example by thinking of it as a fraction to a power. So you took the top to the power over the bottom to the power. Another way of handling it, and I'm going to work it out through this alternate method as well, is to say, well, you could have started by trying to simplify the x's and the y's within the parentheses before we raised it to a power. Let's take that road. As long as you're following your rules in a consistent fashion, it doesn't matter how you look at the problem. Okay, you should still get the same answer. So let's try the same problem again. 3x to the 5th, y to the minus 4, over xy to the minus 1, all to the minus 3 power. Okay, what I'm going to do is to think of this as 3 times x to the 5 over x times y to the minus 4 over y to the minus 1, or to break it up the way we did the other problems, within the parentheses. So within the parentheses, we would have 3. Now, x to the 5 over x to the 1 is x to the 5 minus 1. You keep the base, you subtract the powers. Y to the minus 4 over y to the minus 1 is y to the minus 4, take away a minus 1. When you're dividing, we keep the base, we subtract the powers. This would give us 3x to the 4th. Now, y minus 4 minus a minus 1 is minus 4 plus 1, that's minus 3. Okay, and we could now go right into the rule that says a, b, c to the n is a to the n, b to the n, c to the n. Just distribute the power through the factors here. We have 3 to the minus 3, x to the 4th to the minus 3, y to the minus 3 to the minus 3. 3 to the minus 3 is 1 over 3 cubed. X to the 4th to the minus 3, we have power to a power. We multiply the powers, we'll get x to the minus 12. And y to the minus 3 to the minus 3 is y to the plus 9. Okay. The x to the minus 12 can go downstairs as x to the plus 12, giving us a final answer of y to the 9th over 27 x to the 12, which of course is the same answer that we just got when we worked out the problem before. Y to the 9th over 27 x to the 12. Let's look at that again here. 3 to the minus 3 is 1 over 3 cubed. Okay, that gives us a 27 downstairs. X to the minus 12 is 1 over x to the 12, so that's downstairs. And the y to the 9th is the only thing that stays upstairs. Okay, let's try one more example. Okay. This one is 2a to the minus 2, b to the 3rd, over 3a squared b to the minus 2 power. Okay, first thing I want you to notice is that neither of the two techniques that we used in the preceding problem can be used. This is not a fraction to a power. The top is by itself, the bottom is being raised to a power. So although it is a fraction, you cannot jump right in and use Rule 5, which says a fraction to a power is the top to the power over the bottom to the power. Also, if you'll notice here, the top is by itself, the bottom is being raised to the minus 2 power. We are not free to work with the a's and the b's separately at this stage. If you look in our other approach to this last problem, everything was in the parentheses, and within the parentheses we were able to simplify the x's and the y's. Here we can't. We have part of this being raised to a power and part not. We cannot deal with the a's right now and the b's. We cannot simplify, nor can we treat it as a whole thing being raised to a power. Okay, so we're going to have to work with the denominator separately. Okay, the top we'll leave alone at this stage. And only in the bottom will we make use of the rule that a, b, c to the nth power is a to the n, b to the n, c to the n. Okay, so we'll have 3 to the minus 2, a squared to the minus 2, b to the minus 2. Okay, now we're going to use the rule that says a power to a power. We find that by multiplying the powers. So we have 2 a to the minus 2b cubed on top, and on the bottom 3 to the minus 2 a to the minus 4, multiplying the powers, b to the minus 2. And now I'm going to subdivide this into the 3 simpler problems the way we've been doing that before. Okay, in the first part of the problem, 2 over 3 to the minus 2, I'm going to rewrite that as 2 times 3 to the second power over 1. In other words, this 3 to the minus 2 downstairs I'm going to rewrite as 3 to the second power upstairs. Okay, a negative power downstairs can go upstairs with a positive exponent, just like a negative power upstairs can go downstairs with a positive exponent. Okay, a. Now, we have the division. We have the same base. We're going to subtract the powers. Minus 2 minus a minus 4, and here b 3 to the 3 minus a minus 2. Let's see what we have. 3 squared, that's 9, times 2, that's 18. Minus 2, take away a minus 4, is minus 2 plus 4. That's just plus 2. That's a squared. 3 minus a minus 2, that's 3 plus 2, that's 5. And we get 18, a squared, b to the 5th, the answer to the example. And this is the end of the tape.